This is a podcast for HOPES, the Huntington's Outreach Project for Education at Stanford. In each episode, we'll share stories that shed light on the history and the current issues in Huntington's research. I'm Claudia Haymack. In the last episode, we talked to historian Alice Wexler about the broad history of Huntington's, from the 1800s to the late 20th century. In this episode, we're zooming into a smaller time frame, on the scale of years, starting with 1979, and starting with Alice's sister, Nancy. At the time, Nancy had a job at the National Institution of Neurological Disorders and Stroke. She first took a trip to Venezuela to try to find someone who had 2 copies of the mutant Huntington's gene, to better understand how the disease worked. In San Luis, on the edge of Lake Maracaibo, the prevalence of Huntington's was almost 1,000 times higher than a normal population, making it the most likely place to find someone with 2 copies. A meeting in Bethesda, also in 1979, brought even more gravity to her plans in Venezuela. A new technique had been developed that could actually locate where a gene was in the genome. It was called gene linkage. At this point, nobody knew where the Huntington's gene was, or what its sequence looked like. Basically, the way gene linkage worked is that you would take a sequence with a known location in the genome. Then, test to see if it's located close to your gene of interest. If it is, then you've narrowed down where your gene is. But to find a sequence that you know, and that's also close to your gene, takes a lot of luck, a large number of families, and a lot of testing. Scientists estimated that it would take about 10 years to find the gene. At the Bethesda meeting, everyone was abuzz about gene linkage, and the researchers decided that if it was going to take 10 years, they'd better start looking now. In 1979, Nancy arrived in San Luis. She wanted to get to work collecting skin biopsies, blood draws, neurologic exams, and recording family pedigrees. But she had to gain the community's trust first. Nancy set up a meeting and, in her rudimentary Spanish, explained to community members how valuable their contributions to research would be. She told them that she, too, was at risk of Huntington's, and when people doubted her, she held up her arm, showing that she had done a skin biopsy, too. After that meeting, the project ran full steam ahead. Data was sent to a lab at MIT. 4 years later, in the spring of 1983, a researcher named Jim Gusella at MIT tested out a probe and realized that he had found a marker for the Huntington's disease gene.
So I'm Sandra Lee, and I'm a medical anthropologist, but I've been working in the field of biomedical ethics for, about 20 years or so, and I'm at the Stanford Center for Biomedical Ethics. So my work has mainly been looking at the way in which the public understands all of the genetic information that's coming out.
I sat down with Dr. Sandra Lee to understand the significance of this discovery.
Well, I mean, it was huge. It's an amazing scientific feat, and it relied on a lot of families who have experienced Huntington disease to come together so that they were able to kind of trace where that mutation resides.
Wexler's work mapping the gene was done before the Human Genome Project, before genetics was regularly applied to treating and predicting disease. Finding the gene opened the doors to new ways of targeting the disease. And it opened the door to creating a genetic test.
The Huntington disease set of work, I mean, that is extremely important in showing kind of, okay, if you have a mutation, this actually can be highly predictive in ways that other disease, it may not operate in that way at all. And so it's distinctive.
Since Huntington's is a result of one mutated gene, unlike many other diseases, if researchers could test for whether someone has that mutated gene or not, they could tell with high accuracy whether someone will get the disease.
Having that genetic test might give someone extra information in terms of planning how they want to live their lives, as well as giving information around reproductive decisions, as well as planning for perhaps their children in case they do develop the disease, these kinds of questions.
But given that there's not yet a cure for Huntington's, or a way to prevent its onset, the creation of a genetic test raised some difficult ethical issues.
It can be helpful. I don't know if there's a lot of empirical work around whether or not it actually is indeed helpful when you put it on balance with the potential distress somebody might have or experience when they get a positive genetic test result back.
It's a choice that people at risk have debated ever since the test's creation. Nancy Wexler herself chose not to get tested. But the impact of the Venezuela project went way beyond creating a genetic test for Huntington's. The Venezuela project was critical to understanding how the Huntingtin gene worked and how to even approach looking for cures.
It was extremely significant. It validated this kind of approach to understanding why genetics was so critical in terms of contributing to disease.
If you would like to learn more, Alice Wexler's book Mapping Fate has a detailed account of Nancy Wexler's Venezuela trips. Information can also be found in the Annual Review of Medicine from 2012 and on the Hereditary Disease Foundation website. This episode features Dr. Sandra Lee, a medical anthropologist at Stanford. I'd like to thank the Hopes Fund and Stanford for their support. Thank you to Catherine Heaney, to Crystal, our graphic designer, and to the Hopes team for guidance.